Okay, I hope I'm audible to all students who are attending this lecture. We continue with our lectures on three-dimensional geometry. Okay, we continue with our lectures on three-dimensional geometry in mathematics. And if all students can recall that in the previous lecture of three-dimensional geometry, we were looking at the concept of direction angles, direction cosines, and direction ratios of a directed line in the 3D space. Okay, now we had also done some practice questions based on these concepts. In this particular lecture, we intend to solve questions from exercise 11.1 of NCERT. So we intend to solve questions from exercise 11.1 of NCERT, which is based on the concept of direction ratios and direction cosines of a line in the 3D space. Okay, so let's look at question 1. If a line makes angles, if a line makes angles 90 degree, 135 degree, and 45 degree with the X, Y, and the Z axis respectively, find its direction cosines. Find its direction cosines. Okay, so let's solve this question. We are given that the line is making angles 90 degree, 135 degree, 45 degree with the X, Y, and Z axis respectively. So we can say that let the direction cosines of the line be L, M, and N. Then all of us know, guys, what is L? So 90 degrees is alpha, 135 is beta, and 45 is gamma. So these are my direction angles, alpha, beta, and gamma. So L will be cos alpha, which is nothing but cos 90, which is 0. M will be cos beta, which is cos of 135. Now we know how to find cos 135. I can write it as cos of 180 minus 45. And all students know that cos of 180 minus theta is minus cos theta. So cos of 180 minus 45 is minus cos 45, which is minus 1 upon root 2. All students can recall that cos of 180 minus theta is minus cos theta. Students know this from my lectures on trigonometric functions. And then, guys, my n will be cos gamma. But what is gamma? 45. So cos 45 will be 1 upon root 2. So I can say, therefore, the direction cosines of the line are 0, minus 1 upon root 2, and 1 upon root 2. The direction cosines are nothing but L, M, and N, which are 0, minus 1 upon root 2, and plus 1 upon root 2. Okay, so moving forward, let's look at question 2. Find the direction cosines. Find the direction cosines of a line which makes equal angles with the coordinate axis. Okay, so this is the question given to us. Let's quickly read the question again. We need to find the direction cosines of a line which is making equal angles with the coordinate axis. So we can say let the direction cosines of the line make an angle theta with each of the coordinate axes. Okay, suppose guys suppose the direction cosines of the line are all making a common angle theta with each of the coordinate axes x, y and z. So then I can say that L is equal to cos theta, M is also equal to cos theta, N is also equal to cos theta. Remember, L, M and N are direction. L, M and N are direction cosines. And since my line is making equal angle with the coordinate axis, L, M and N, all three of them are equal to cos theta. Now, L square plus M square plus N square is equal to 1. All students can recall from the vector algebra lectures where we had done that the sum of the square of the direction cosines are all equal to 1. So I can say therefore cos square theta plus cos square theta plus cos square theta is equal to 1, which implies 3 times cos square theta is equal to 1, which implies our cos square theta is 1 upon 3, and this implies my cos theta will be plus minus 1 upon root 3. So what will my direction cosines be? My cos theta has come out as plus minus 1 upon root 3. Therefore, I can say that the direction cosines of the line equally inclined to the coordinate axis are, what are my direction cosines? My L is also plus minus 1 upon root 3. My M is also plus minus 1 upon root 3. My N is also plus minus 1 upon root 3. So the direction cosines of the line which is equally inclined to the coordinate axis are plus minus 1 upon root 3, plus minus 1 upon root 3, plus minus 1 upon root 3, which is my answer for this question. So hoping students are clear with this and have no doubts. Let's quickly look at question 3, guys, of the exercise. If a line has the direction ratios, minus 18, 12, minus 4, then what are its direction cosines? What are its direction cosines? So guys, we are given the direction ratios of a line and we need to find the direction cosines. Now, how will I find this? Okay, so first of all, recall direction ratios are given to us. So direction ratios which are given to us are minus 18, 12 and minus 4. This is nothing but A, this is nothing but B, this is nothing but C. Remember, direction ratios we used to denote by A, B and C. Now all students recall from my previous lecture, how do we find out direction cosines from direction ratios? So recall that L is nothing but plus minus A upon the square root of A square plus B square plus C square. M is equal to plus minus B upon the square root of A square plus B square plus C square. N is equal to plus minus C upon the square root of A square plus B square plus C square. And the sign of the direction cosines depends on the sign of the direction ratios. If your direction ratios are positive, direction cosines will also be positive. If your direction ratios are negative, direction cosines will also be negative. So if I quickly solve, my A is minus 18 upon square root of minus 18 square plus 12 square plus minus 4 ka square. Okay, this is what we get. And if I further solve this up, what do I get, guys? What is the value of L I get? Minus 9 by 11 if you work it out. In your registers, if you work out, it comes out as minus 9 by 11. Okay, you can clearly see since my direction ratio is negative, my L, which is my direction cosine, is also negative. M will be B. What is B? B is positive, so I take plus 12 upon square root of, again, minus 18 square plus 12 square plus minus 4 square. Again, it comes out as, you work it out, it comes out as 6 by 11. And if you find out N, it's plus minus C, but C is minus, so I'll take minus 4 upon the square root of minus 18 ka square plus 12 square plus minus 4 square, and if you work it out, it comes out as minus 2 by 11. So you can clearly see in this question that we were given the direction ratios. From the direction ratios, we have found out the direction cosines. So the direction cosines are minus 9 by 11, 6 by 11, and minus 2 by 11. Okay, moving forward to the next question, question 4. Show that the points Show that the points 2, 3, 4, minus 1, minus 2, 1, and 5, 8, 7 are collinear. Now guys, there are various methods to show collinearity. In my lectures on vector algebra also, all of you could see how did we use to show collinearity. We were given 3 points, we used to find 3 vectors, and we used to show that magnitude of one vector is equal to sum of the magnitude of the other 2 vectors. Even that method was fine. But since now we are having lectures on 3-dimensional geometry, we will be using the concept of direction ratios and direction cosines to show that these 3 points are collinear. So I can say consider the 3 points. Point A is given by the coordinates 2, 3, 4. Point B is given by the coordinates minus 1, minus 2, 1. And point C is given by the coordinates 5, 8, 7. We are given these 3 points. We can quickly calculate the direction ratios. So all students can recall, if I calculate the direction ratio of AB, direction ratios of AB are what? They are nothing but minus 1, minus 2, comma, minus 2, minus 3, comma, 1, minus 4, which are nothing but minus 3, minus 5, minus 3. And guys, if I find the direction ratios of BC, direction ratios of BC are 5 minus minus 1, that means 5 plus 1, 8 minus of minus 2, 8 plus 2, 7 minus 1, so this comes out as 6, 10, and 6. Now what do we see? Clearly, the direction ratios of AB and BC are proportional. All of you can clearly see on the screen that minus 3 upon 6 is exactly equal to minus 5 upon 10 is exactly equal to minus 3 upon 6. Now, since the direction ratios of AB and BC are proportional, therefore I can say that AB is parallel to BC, but since B is common to both AB and BC, what does that mean? If I say that AB is parallel to BC and B is the common point, it means A, B and C are lying on the same line. So I can say that A, B and C are collinear. A, B and C are collinear. So quickly revising the solution again, we were given these 3 points A, B and C. We found the direction ratios of AB. We found the direction ratios of BC. We have observed that both the direction ratios are proportional to each other, because if you work them out, they are all coming out as minus half. And if direction ratios of AB and BC are proportional, that simply means that AB is parallel to BC. Now AB is parallel to BC, but B is the common point. This simply means that A, B and C are lying on the same line, and if they are lying on the same line, it means that they are collinear. Okay, and then quickly let's look at the last question of this exercise, after which we stop. Question 5. Find the direction cosines. Find the direction cosines of the sides of the triangle. Find the direction cosines of the sides of the triangle whose vertices are 3, 5, minus 4, minus 1, 1, 2, and minus 5, minus 5, minus 2. Okay, so we need to find the direction cosines of the sides of the triangle whose vertices are given by these 3 coordinates. So I can make a figure first. Let me make a figure for this. This is actually a triangle, guys. If I actually take these 3 points in the space, it becomes a triangle. Point A, which is 3, 5, minus 4. Okay, then we have point B, which is minus 1, 1, and 2. And then we have point C, which corresponds to minus 5, minus 5, minus 2. So this is my triangle ABC with the vertices as indicated in the diagram. Okay, so let's work this out. Now, what is the question asking us? We need to find the direction cosines of the sides of the triangle. So guys, first of all, let's find the direction ratios. Okay, let's first find the direction ratios. Okay, so the direction ratios of AB, the direction ratios of AB are minus 1, minus 3, 1, minus 5, 2 minus of minus 4, that makes it 2 plus 4. So this is nothing but minus 4, and 6. So these are the direction ratios of AB. Now similarly, guys, we can work out the direction ratios. What are the direction ratios of BC? So I can say that the direction ratios of BC are minus 5, minus of minus 1. That makes it minus 5 plus 1, minus 5, minus 1, minus 2, minus 2. So this becomes minus 4, minus 6, minus 4. And similarly, guys, direction ratios of direction ratios of CA are 3 minus of minus 5, or I can take it as minus 5 minus 3 also. So I can take minus 5 minus 3, comma, minus 5 minus 5, comma, minus 2 minus of minus 4 makes it plus 4, which are minus 8, minus 10, and 2. Okay, so this is what we get. Now, once we have got the direction ratios, we can quickly find the direction cosines. Okay, so if I find the direction cosine, so direction cosines of AB are minus 4 upon the square root of minus 4 ka square plus minus 4 ka square plus 6 ka square, comma, again minus 4 upon the square root of minus 4 square plus minus 4 square plus 6 square. Okay, and another would be 6 upon the square root of minus 4 square plus minus 4 square plus 6 square. Now if you work this out, guys, my direction cosines of AB are coming out as, you can work this out and you can check, it comes out as minus 2 upon square root of 17, minus 3 up, minus, this will also be minus 2, minus 2 upon square root of 17. Okay, and the last one will come out as 3 upon the square root of 17. So these are my direction cosines of AB. I hope students have understood the formula which we have used. Okay, so if I erase the question now, I hope that students have understood the formula which we have applied in this case. Okay, so I hope students know how to find the direction cosines from the direction ratios. Okay, so this is nothing but minus of L upon under root. This is nothing but minus A upon under root A square plus B square plus C square. I mean, I hope students know how to calculate direction cosines from the direction ratios. Please look at the formula showing the relationship between direction cosines and direction ratios. Similarly, if I have to find direction cosines of BC, they will be minus 4 upon the square root of minus 4 ka square plus minus 6 ka square plus minus 4 ka square, comma, minus 6 upon the square root of, again, minus 4 ka square plus minus 6 ka square plus minus 4 ka square, and this will be minus 4 upon the square root of minus 4 ka square plus minus 6 ka square plus minus 4 ka square. So if you work it out, guys, what will come? So if I erase the diagram now, students know the diagram. You can quickly calculate the direction cosines of BC, and they come out as follows. Minus 4 upon 2 times the square root of 17 minus 6 upon 2 times the square root of 17 and minus 4 upon 2 times the square root of 17. So these are my direction cosines of BC, and on similar lines, let's quickly find out the direction cosines of CA. Now they are minus 8 upon square root of minus 8 ka square plus minus 10 ka square plus 2 ka square, comma, minus 10 upon the square root of minus 8 square plus minus 10 square plus 2 square. Okay. And the last would be 2 upon the square root of minus 8 ka square plus minus 10 ka square plus 2 ka square. So if you solve these, you get the answer as minus 8 upon 2 times the square root of 42 minus 10 upon 2 times the square root of 42, 2 upon 2 times the square root of 42. So this is my direction cosines for CA. So I hope students have understood the solution for question 5. We were given 3 vertices of a triangle. First of all, we found the direction ratios of AB, direction ratios of BC, direction ratios of CA. These are the direction ratios we got. Then students know how to find direction cosines from direction ratios. Okay, so we had done this before as well, the relationship between direction cosines and direction ratios. We directly apply the formula. Okay, we get direction cosines of AB, direction cosines of BC, and direction cosines of CA. So with this, guys, our exercise 11.1 of NCERT is completely over. Okay, so this is where I intend to stop in this particular lecture. We will continue with our lectures on 3-dimensional geometry in the next lecture as well. So I hope all students have enjoyed this lecture. Any doubt, you can unmute your mics and ask, or call up, or mail me your doubts at divineschoolofelconomics@gmail.com. So this is where I stop in this lecture.